Thank you, everyone, for waiting. And we are ready. We are starting our session about Cosmos DB made easy with Azure Functions as part of the MSP Tech Americas event. Thank you very much for joining, all of you. And I hope that during this hour you learn a lot from this presentation. My name is Luis Beltran. I am a Microsoft MVP from Mexico. Currently, I'm living in Czech Republic because I am studying PhD. I can talk a bit about me in the next slide. But
And
yes,
Luis? No,
yes,
okay, you can continue. I only like to make a little introduction, okay, to everybody. So you can start your presentation, okay?
I can. Sorry, I didn't
I will only make an introduction for everybody about
Ah,
MSP Tech Days,
sure.
okay? So you
Yes,
can start
yes.
your presentation later, I can talk, okay?
Go ahead, go ahead. Yep.
No problem. So welcome aboard to the first day of MSP Tech Days. And so happy and excited to start this project. And the objective of MSP Tech Days is a project of technical training to people all over the world. So it's a project that is not only from MSPs from Brazil, but from Microsoft and partners too, so on all around America. And let's start. And I'm going to start here talking that the MSP program is for open for applications. So we start students advertise with our knowledge of what. And it can be open to submit your application, okay? And today, and you understand, we have online MSP technique sessions all of the month of June. So we start with coach, that's this week. We will start with the next week with data and later with mobile. And we have development more connected to the month of June. And in July, we have a track of innovation, okay? And with this track of innovation, we're going to talk about how was the experience of the to MSP Summit 2 on inside on Seattle. That was a great experience too. Okay, so let me share a little my screen here with you. Oh, I hope everyone is seeing my track. And it's here, okay? The Microsoft City Partner Program is open for application. So if you are students, if you are interested to share knowledge with everyone, you are more than welcome to become part of the program. It's a program that is really great, and you have to start the MSP Tech Days on the Saturday. So we start on the Saturday with the presential events that happen in all over Latin America. So in the total, we had around 4 countries the MSP program happening. So we have it happening in Brazil, in Peru, and in Nicaragua, and in Mexico. We have MSP Tech Days happening too. And we have around the month of June too this technical online training happening in the webinars. Okay, so here's the process, and it's such a great experience, and bringing people from all over Latin America to can we talk with you and everybody. Okay, so it's right here, and I will pass to Luis to start the presentation over to you. Okay, Luis, it's with
Okay.
you.
Yeah. Thank you, Orlando. Okay, and then we can start with our presentation without uh, anything else. So my name is Luis Beltran. I am a Microsoft MVP from Mexico. I'm currently living in Czech Republic because I am studying a PhD. So thank you very much for joining. Okay. So thank you, Orlando, for the introduction, and welcome everybody to this presentation about Cosmos DB made easy with Azure Functions. I hope that during this hour you will learn a lot. My name is Luis Beltran. I am Microsoft MVP in Developer Technologies from Mexico. I was formerly a Microsoft student partner, so I'm really glad to participate in the MSP Tech Americas edition of 2019, which started last weekend with events in Brazil, Mexico, Nicaragua, and Peru from our colleagues, MSPs. So in this online session, I will be talking about a NoSQL database platform, which is Cosmos DB. And well, if you have any questions at any time, just let me know in the chat. This session is live streamed in two different places, so I will be checking both chats. Okay, so feel free to um, ask me any questions about the topic if you have any doubt. So as I said, well, I am from Mexico. I am currently a researcher at Thomas Batia University in Slin, which is in Czech Republic. I am finishing, hopefully, my studies this year, and then we will see what happens next. In Mexico, I was a lecturer or professor at Tecnológico Nacional de Mexico in Celaya. I mostly work with databases, programming, mobile software development, or particularly with .NET technology, C Sharp, and so on. So, yeah, my expertise is more about C Sharp, .NET, Xamarin, and of course databases. Well, here you can also see my email, blog, and Twitter account in case you would like to contact me after the session. So yeah, feel free to reach out. And let's get started with our topic. So what is Azure Cosmos DB? Azure Cosmos DB is one technology from Microsoft. It's a NoSQL database platform which is hosted in the cloud, in the Azure cloud. It's a solution for particular scenarios, such as global distribution of a database. You can see that we may have a database which is replicated or which is distributed in several regions, maybe North America, South America, Africa, Asia, and so on. The idea is that we can have such advantages like geo-replication of data, unlimited scale storage, because, well, we can uh, take advantage of each server or data center where we have our data stored. And well, another important thing about Cosmos DB is that we can access the information by using several APIs. Maybe a famous one is SQL API, so we can run SQL queries such as select a star from a table, or we can also use JavaScript or table API. If you have worked with Azure table storage, well, it's more or less similar. But there are also other APIs such as Gremlin, Cassandra, or MongoDB, which is also a famous one. So it is up to you which one you would like to use. Uh, in the end, you have documents, you have collections, you have a set of keys and values uh, where your data is stored, and you can perform uh, route operations such as retrieve information, add, update, and so on. But the basic idea here in Cosmos DB is that your database is distributed, um, and is or can appear in several places. Okay, that's the main idea behind Azure Cosmos DB. And in this model, there are several advantages, such as global distribution, elastic scale out, low latency, consistency models, and the service level agreement. And we might talk about them in the next slides. So first of all, global distribution. As you can see, well, we can have our database located in or replicated in several data centers. We can decide to start storing our information in, let's say, West Europe data center. But then we might have a backup or another server, let's say, in North America. So in case that the server of West Europe has some problems, our users can still access the data because we have a backup server, or we have another data center where our information is stored. So we will not have, let's say, problems from our users accessing our data. So that's one of the advantages behind Cosmos DB model. Of course, it also implies that it will be a bit more expensive because now we are talking about two data centers, but in the end, it means that there is no failure in our service. So yeah, that's also another thing to consider. Cosmos DB is particularly designed for environments where you have millions of data, a lot of information that you want to access. And maybe it's distributed by regions or by countries or by zones. If you have heard about distributed databases, you know what I am talking about. You know that there is, for example, horizontal distribution. Horizontal distribution is when you have your data, let's say customers at a customers table, and you want to partition your table. Let's say customers from Mexico, customers from Brazil, customers from Germany. So you have your whole customers database or table, but in Germany, you will only access customers from that country. In Mexico, only Mexican customers. In Brazil, only Brazilian customers. So it means that we don't need access to the whole database. We can distribute or we can partition our table only to the information that we need. Okay, it seems that there is a problem because I would like to ask if you can see the slides, because somebody told me that it's not available, but okay, I would like to ask if you can see my screen. Sorry for the interruption.
Luis, it's alright?
Your goals of the database. Actually, when your goals of the database. Actually, when
Great, Luis. So that's it.
Os eventos que a gente participou do evento de treinamento, mas amanhã o vídeo vai estar lá no canal vai nascer no canal da manhã. Pode ser que você tenha conhecimento dados que você estava recebendo,
Posso saber por que o senhor está se isolando?
Oi?
Posso saber por que o senhor está se isolando?
Tô em live.
Está justificado, mas que isso não se repita.
Sim.
Só brincando.
Só os BOs. So, And thank you so much, Luis, for the presentation. And guys, you saw that the presentation of Luis had some problems. So we'll share later the link for presentation from Luis' channel. Okay, so you can check it there, all the presentation, and see later if the song and all the presentation. Okay, all right. So we start the second presentation of the night with Eric. Eric, are you there?
1 second. Yep. Orlando, can you hear me?
Okay, I can hear you. So, please, you can share your screen with us.
All right.
Yeah, I can hear you.
All right. Can you see that?
Nice. I'm receiving your. Oh, okay. Nice. I'm receiving your presentation. Let's see here if you can see.
All right. And let's
Okay.
see if we can get the audio checks on.
Nice. I'm receiving your.
Perfect. Alrighty. Orlando, am I good to go? And let's get started.
There are big companies being hit by SQL injections all the time, still in 2016. And
Okay, you can go.
then also using.
All right. So hello, everyone. My name is Eric Zhang. I'm a engineer from the US MSP. Today, I'll be talking about how you can prototype solutions with Azure IoT, starting from your device and then going all the way into the cloud. And I want to focus specifically on that pathway from the device into the cloud because there's a lot of things that happen in between. And hopefully, we'll be able to dive deeper into some of those topics. So again, my name is Eric Zhang. I was a US MSP from 2016 to 2018. Now I work as a systems engineer at Leverage, which is an IoT startup where we focus on building enterprise IoT solutions. But we also do a bunch of rapid prototyping and systems integration. So hacking things together is a pretty significant part of what we do. I also write at IoT for All, which is a publication where you can find, it's basically the Wikipedia for IoT content. And so hopefully that's a little bit about me, but now I'd like to move into what we'll be talking about today. So brief agenda, I want to talk briefly about what IoT is before moving into devices and sensors, talking about connectivity. So this is things like Wi-Fi and Bluetooth, how you get your data from your sensor, from your device into the cloud. And then finally, how you leverage Azure to build those IoT solutions, what components you might be using, and how do you turn something like a raw 16-bit value into a meaningful insight that you can use for your solution or for your end user. So to start out, I know this is very basic, but there's often this question of what is the Internet of Things? And I think a lot of developers especially come in with an incomplete understanding of this because there's a lot of different types of developers. You could be someone who builds front-end work, you could be someone who builds cloud infrastructure, or you could be a hardware or firmware engineer working with devices on the ground or deploying things in the field. So there are a lot of people with different backgrounds, and so there's a pretty big overlap in expertise. So IoT is formally defined as a proposed development of the internet in which everyday objects have network connectivity, allowing them to send and receive data. What that basically means is the ability for everyday ordinary objects, so people, animals, things, could be your cell phone, it could be your oven, the ability for those things to send and receive data wirelessly and to communicate. And what that actually looks like in practice is something like this. So this is a project that I actually worked on a couple years back where we were tracking some marine mammals in the southern part of Florida. And there's a lot of different components that are happening here. On the left, you can see that there is hardware. So there's physical hardware that enables our ability to acquire data. In this case, we're using a microcontroller with cellular connectivity. There's a battery inside. We have to think about the form factor because there's environmental considerations like it needs to be waterproof because we're dealing with aquatic animal tracking. There's also, on the cloud side, we have to think about the type of data that we're working with. What kind of payload are we getting? What kind of information do we care about, if that's temperature, pressure, humidity, GPS location? Finally, how do we process that data and get it to the end user at a point where it's easily digestible and easily used? So in this case, since the application is tracking, what we want to see is a map of those positions, and we want to be able to plot those paths, that movement over time. And so that's what you see on the right is an actual tracking of that particular asset, the tracking tag that we built throughout that experiment. And so I'm going to use this example as we go through this talk because I think it's very valuable, and it shows the full architecture of what you can do, especially when you're prototyping a solution with IoT. You want to do something that's fast and effective so you can demonstrate that it works, even though this may not necessarily be your end architecture for something that's more refined and enterprise grade. So there are two basic IoT architectures. Generally speaking, you either have examples where you're passively acquiring data from physical devices, and you're either getting them from the internet and then sending them into the devices, or other way around, where you're getting something from a device and then sending it into the internet so that you can get some kind of notification. And you see this a lot with applications like where you're collecting telemetry or sensor data from the environment, if you're tracking location. These are very common and very, very well understood. The other is a little bit more complex. I call it active system control. Essentially, you're enabling a bidirectional communication of data, both from your device to the user. And you see this more in applications like smart home or home automation products. So if you're talking to your Google Home, it interfaces with the cloud and it comes back to you with a response. Or if you're controlling a Philips Hue light bulb with your phone, you're sending a wireless message and then you have a physical change, but there may be an automation that takes sensor data that then automatically causes that light to turn on or off. So there needs to be a two-way there. So let's go into the basics. We have devices, we have some kind of connectivity, and then we're moving into the cloud. To start out, we need to acquire data. And so this could be anything from GPS location data. It can be sensor data like light, temperature, sound, pressure, or distance. But ultimately, it looks something like this. You have some kind of board. It can be a microcontroller. It can be a computer like a Raspberry Pi. But you're wiring it physically to a sensor module, and you're using that to acquire data either with some demo code or with your own firmware and software. And this gives you information about what you're looking for. In this case, I'm using a BME 280 module to measure the temperature, pressure, approximate altitude, air pressure, and humidity levels in the environment. I can then use this to stream data in and maybe run some analytics, for example, looking at trends over how the environment is changing throughout the course of a day, a week, a year, and maybe even running analytics on that. But to start out, you need that raw information. And so there are a lot of different types of sensors, light, temperature, humidity, pressure. Depending on your application, you'll be using different types of modules. But in the end, the concept is still the same, which is you have some kind of controller, some kind of board that has intelligence that you can use to write and flash firmware onto. You can use that to then gain data by sending in power, ground, and some input pins. And then you can use that to get something meaningful out of it. And that's the basis for data aggregation, for data collection. So here's where we are right now. And the next piece is the hardware that we're using. What kind of devices are we using to get this data? To start out with, for IoT applications, Arduino, Particle, and Raspberry Pi are, I think, the easiest platforms to get started with. But if you have some more experience, you're obviously not limited to those. And so there are two types, generically speaking, there are two types of boards that you can work with. The first are microcontrollers or MCU boards. Boards like the Arduino MKR1010 or the Espressif ESP32. These are small boards that have limited flash memory. So you can only do so much in terms of what you can program onto there. And so you really can't do things like machine learning or AI. But on the other hand, what you can do is actively collect a lot of data for a very low amount of power consumption. And this allows you to deploy a lot of different sensors across a very large area without worrying as much about cost. On the flip side, if you're doing more intensive edge computing applications, for example, there are countries that are starting to work on facial recognition cameras. Well, the facial recognition processing happens at the edge because there's a vast amount of data that's coming in from that video streaming. If you wanted to send that and process that in the cloud, that would be extremely expensive. And so a lot of those innovations are happening at the edge because it's cheaper and it's more efficient. So these are devices like Raspberry Pis, or also, for example, the Intel Dragon Board 410C. The trade-off is that you get essentially a Linux machine that can run these computations, and so you get a lot more ability to do different types of applications, but you spend a lot more power, and it's a lot less efficient, and it's also much more expensive to use on a per device level. So I want to talk about the microcontroller platforms in particular. I think it's really important that you pick the right platform to start off with, especially if you're a developer that's just getting into IoT. So Arduino is, I think, the best place to get started. And built along that particle is very similar to Arduino in the sense that it programs the exact same way, but they manufacture boards specifically for IoT applications. So if you're doing Bluetooth, or if you're doing Wi-Fi based or cellular based IoT prototyping. So this now goes into how you program your devices, what is happening there. And so if you're a developer, you may be familiar with C. In this case, C is used to program these devices because you're very memory limited, something like 32 megabytes of RAM. And so you have to be very efficient with what you're doing, but you also have a very structured program format. So in this case, you have a void setup loop that is used to initialize your programs, and then you have a void loop which runs continuously in the background. And so this works very well for if you're trying to aggregate sensor data, where you just want to initialize and then continuously stream in data. Now, keep in mind, if you're working with Raspberry Pi or Intel Dragon Board, you can use more intensive programs or programming languages, more, for example, like Python. And that's because these are basically Linux machines. They have more to work with in terms of memory. But for something like an Arduino, it's very difficult to do that because if you spend all of your compute on trying to process these high-level languages, you won't have enough to do your actual application. And just to show you, Particle works roughly the same way. So this is C code. This is firmware that gets flashed onto the device. You have a void setup, a void loop that runs continuously. And this kind of paradigm can be used with all of the different boards that run on the Arduino environment, from Espressif to Adafruit and so on. So we've got our devices. We talked about sensors. We've talked about how you actually program your devices. Now we are going to get into connectivity. And there are many different types of connectivity options. Here are some of the few, and we're going to go into a few more after this. So connectivity is how you get your data into the cloud, and it's also how you communicate data between devices, even at the edge. And so there are a couple different types of connectivity that we're going to talk about today. The most dominant are Wi-Fi, Bluetooth/BLE, Bluetooth Low Energy, and cellular. And these are common for a couple different reasons. Mainly, it's very easy to transmit data, and they're widely used in different applications. But also because they're relatively inexpensive because of how often they're used. The second subcategory of this is LoRa. So LoRa stands for long range. It's a wireless protocol in the sub-gigahertz frequency. And it's widely used in Europe and North America for applications where you want to transmit data across long ranges, but be very battery conservative. I'm excluding this from the main Wi-Fi, Bluetooth, and cellular category because while it is very useful, it still has limited applications in kind of the prototyping space because you do need to deploy your own LoRa server and LoRa gateway in order to make that system work. The third category is Zigbee, Z-Wave, and Thread. And these are all communication protocols that are used for smart home technologies. So if you have a SmartThings hub, that's going to be either Zigbee or Z-Wave, depending on if you're doing door locks or smart thermostats. If you have a Nest thermostat, that's actually running on Thread. Thread is a relatively new protocol, but it runs on the same spec as Wi-Fi, so 802.11.4, I believe it is. And so these are ways to communicate data locally between devices, and then ultimately they'll use a backhaul like Wi-Fi to send data into the cloud so that the user can interact with it. And then finally, there's satellite, which you see more in industrial and enterprise grade IoT applications, but I'm putting it here because it is used and it's good to know about, just because it is another IoT communication protocol. So as a developer, you probably are thinking about what boards you should start out with, maybe what you want to work with. But it's important to think about first, before all of that, what your application is and how you want to use it. So there are a lot of different types of prototyping and development boards, and each one is catered to a very particular use case. So for example, with Particle's family of boards, if you're looking to do an application with Bluetooth mesh, they're actually the only boards that you can use right now that you can use to develop on a mesh network. And that's because they're using a particular Bluetooth chip from Nordic Semiconductors. But if you're looking for, let's say, a Wi-Fi and Bluetooth, or maybe just an exclusively Bluetooth application, and you want to be able to get into the nitty-gritty of establishing an active Bluetooth connection or sending BLE payloads once every 5 seconds, then you maybe want to use only a Bluetooth chip. The reason for that is because every additional add-on to the technology is an additional cost, but it's also an additional battery expenditure. So if you think about it, if you're working with a remotely powered device that's not plugged in, you have limited bandwidth in terms of how much power you're using. And if you have something that's very intensive, then you're going to need a bigger battery. On the flip side, if you're looking for just Wi-Fi applications, you can use the Particle Argon, or you can use the Maker 1010 board, or you can use the ESP32. Doesn't make too much of a difference. The main difference actually is just the interface that you're using to program it with, and the amount of documentation that you have available. The other types of boards that you could use are more in the computer class. So these are essentially Linux machines, Raspberry Pi and Raspberry Pi Zero. The benefits here, though, are that because they are essentially computers, you can use the USB ports on the Raspberry Pi 3 to add additional connectivity. So if you want to build a LoRa application, or if you want to build a Bluetooth or Zigbee application, you can buy a modem on Amazon and just plug it right into the port, and then you'll have that connectivity and be able to interface with that connectivity, whether it's through an AT command set or something else. You can also use these computers to act as gateway devices for sensors that are deployed locally. So if you're running maybe a network of sensors that are gathering data from microcontrollers, let's say over Bluetooth, you can use those to transmit over Bluetooth to the gateway device, in this case a Raspberry Pi, and then that gateway device can then funnel all of that data, batch upload into the cloud, into, let's say, Azure IoT Hub, and then now you have a lot of data, but you don't need to overly burden your wireless network. All right, so we finished connectivity. Now we're going to talk about the cloud. And the main job of the cloud is to do a couple different tasks: processing, storage, analytics, and intelligence. And so this is where we do a lot of things like cleansing data for bad or invalid entries, throwing it into a pipeline for analytics or business insights, storing it for future reference, or even performing more complex analyses like machine learning or AI. And this is really important because a lot of these analyses cannot be done at the edge purely because of the memory constraints that you have, but also because all of that data is being collected individually and there's no single aggregation point. So one of the benefits of having a network or a system where you have a lot of different devices communicating to a single gateway is that gateway device can then perform some of those calculations at the edge before sending it into the cloud. And so this is where we get into Azure. And there are a lot of great tools here that you can use to build IoT applications. You're not limited to just a single service or a single set of services. And so it can touch from anything from like cognitive services and Machine Learning Studio to Azure Functions and Power BI. But I'm going to touch on 4 that are crucial to prototyping with IoT here. And these are for building solutions that are quick, not necessarily building solutions that are the best for like a full-scale deploy enterprise for hundreds of thousands of customers. So with IoT applications, you're going from device to cloud. The most important piece here is IoT Hub. And this is your data ingestion tool, but it also provides you a way to authenticate your devices securely and manage your devices. You cannot do IoT without data ingestion. The second piece is Stream Analytics, and this allows you to do real-time event processing. This is essentially a way for you to take your data perform the calculations or the computations that you need on it, and then pass it into your other services, whether that's storage, whether that's Azure Functions, whether that's Power BI, or even something else entirely. This is your data cleansing pathway. The third is Azure Functions, and this is a serverless compute service that lets you trigger actions, scripts, or small pieces of code. The important thing here is it lets you trigger things. And so if you're running an IoT application with tracking, oftentimes you care about, for example, let's say something exits a certain vicinity. If you're tracking an important asset, you may want to care about where that asset is located and maybe get notifications for it. If your home triggers an alert, like a fire alarm, you want to know about it. All of these different types of notifications, or in this case, it could even be something like, we received this amount of data. Let's trigger a machine learning run on and update our model. This is really important because it allows you to be continuously updating and continuously improving your system, both for your users and internally. And finally is Power BI. And this is a business intelligence tool. It allows you to create really good visualizations that are interactive, and it helps make your data a lot more meaningful. And for someone who doesn't have front-end experience or experience building these kinds of visualization tools like myself, I'm more of a hardware and electronics person, this is really valuable because it saves me a lot of time. And it turns all of that raw data that otherwise seems kind of ugly into something that's really, really powerful. So if you're looking to build a more formalized IoT architecture, here's a reference architecture that I pulled from Microsoft. So this takes you through their entire pathway, starting from things, building into what they call insights, and then finally turning it into actions. So you can see here there are a couple of additional tools that are incorporated within this architecture, and there are very good reasons for this. If you're looking at an enterprise-grade IoT deployment, you're talking about potentially hundreds, thousands, even millions of devices that are sending in data. You need a way to be able to manage that, and so that's why they have a bulk device provisioning service. Moving forward, you need ways to both manage that data, transform that data, as well as process it, store it, both in the short term as well as in the long term. And this is important because you use those for very different applications. In a warm path store, you might use it directly and send it into a UI. But in a cold path store, you might send it into machine learning to be able to deploy a model, gain some more insights, or maybe be able to point out some anomalies. Finally, there's things like user management and business integration that typically you don't do in a prototype because there's no need. At that point, you're proving concept. You don't need to do those kinds of large-scale applications. And so they typically get cut out. But I want to bring this in anyways, because I think it's important to see how a full architecture plays in compared to something that's stripped down for a prototype. And so here's an architecture that you can use when you're just building a very quick proof of concept, or even a prototyping application that you can use maybe for a startup moving into developing your own projects. So you can do something quickly, but there's a little bit of everything for each comfort level. And so you can set up components. Once you've gathered your data from your hardware and you've ingested it, you can play around with the different components. Generally speaking, though, once you have your devices sending data into IoT Hub, you can send it wherever you need to, whether that's storage, Stream Analytics, Cosmo DB, Power BI, or a custom application. Now, I'm going to start talking about device authentication. So with Azure IoT Hub, with IoT in general, one of the main concerns is how do you authenticate data? How do you ensure that you don't get a security breach? There's a lot of news about how this system has been hacked, or these people have been compromised because their devices were the vulnerability. And so Azure uses something called X509 CA certificates to securely authenticate devices. This is essentially the gold standard for device authentication within the IoT industry, and you'll see similar mechanisms with other major cloud providers as well. Essentially, there's a public key and a private key, and this pair allows you to verify the origin of the device and ensures that the associated data hasn't been tampered with. And this is really important because there is a key that lives on the device and then a key that lives in the cloud, and this allows you to ensure that the device is not a bogus device or maybe a malware attack. And most newer MCUs, microcontroller units, have a built-in microchip, either the ATEC 508A or the ATEC 608A crypto element that allows you to securely generate and store some of these keys. The second is data communication, and so there are a couple ways of doing this. Typically, the protocols that we use are HTTPS or MQTT. Azure also supports AMPQ, though I personally have not used that as often. And depending on the hardware platform that you're using, there are open source libraries that you can use to support each of these protocols. But again, HTTPS and MQTT are the most common. Now I'm going to get into particle integrations with Azure, and that's because a lot of this happens, actually a lot of these steps happen on the firmware level, so you have to write out sharing your key, provisioning, setting up those communication messages, all those functions, all that happens on the firmware. And so if you're not comfortable with writing that, then you can kind of skip that step by working with Azure IoT with particle hardware. And so they have Wi-Fi, they have Bluetooth, and they have cellular boards for your development needs. But essentially, they've already built out that integration. So what happens is you connect your particle device to the cloud, to the particle cloud, and then you essentially create a server-to-server connection between particle and Azure to get your data into IoT Hub and into all the other Azure services. So what that integration looks like on the particle side is you create the integration on the particle interface. And on Azure, once you create an Azure IoT Hub service, in the shared access policy, you grab your key and then you send it down into Particle. And that initiates that connection that allows Particle to be able to publish data into Azure. And one key point is once you get data into Azure IoT Hub, that data isn't stored anywhere. So even though it's arrived, because it's just an ingestion point, unless you're sending it into a database, that data is lost. So again, this goes into a little deeper into specifically like the JSONs that you might use. In this case, we're talking about manatee tracking. Then we care about the location data, the device ID, and the publication time. And so this tells us where the animal is, which animal is it, depending on which device is associated to it, and at what time we receive that information. The second piece to this is stream analytics. So once you take IoT Hub and you've set it up with, and it's obtaining data, the next piece is to send your data to other tools inside of Azure, whether that's storage, processing, or visualization. And so right out the bat, you can use the output profile to send data from IoT Hub into Stream Analytics, and then further on into other resources. So if you want to immediately run some functions on it and do some kind of processing, you can do that there. But if you just want to send that raw data in, and so in this case, we've already formatted our data into a JSON payload, then we can do that. And so here we're sending it into a Power BI visualization service. And so you can see here, there's actually a lot of raw data coming in. And we have our device ID, we have a longitude, a latitude, and our publication time. And so the real value here is if you're not familiar with how to build UIs or how to build front ends or even deploy things, you can use this information to really quickly spin something up that you can show to your friends or show to your coworkers or pitch to someone else that you might be demonstrating this for. And so this is kind of what that looks like. So there are mapping tools within Power BI as well as graphing tools and other analytics that you can use that'll allow you to pinpoint where exactly a specific device or set of devices are. And in this case, we were running our local experiments in Pittsburgh, Pennsylvania in the US, but we were running our live deployments in the western coast of Florida, which is why you see those 2 points highlighted. Now, if you're not willing to use Power BI, or maybe if you want to build something on your own, I've done an example of that here. And so you can export your data and build your own visualizations with other APIs, or maybe just generate them yourself. Personally, I'm not very good at building UIs. So I had this hosted on WordPress with Google Maps API. And it's very rough, but it at least shows you the precise pathing of the individual animal based off of the GPS points that we're receiving. And so this kind of shows you the end-to-end of, you start with your device, you select your hardware based off of the requirements that you have, and then you move forward, and then you write your firmware to connect it to the cloud. Once you've connected it to your cloud, you then have to figure out how you want to process your data. In this case, I'm not doing very much, but for other applications, you might get more intensive. Once you've processed your data, you then send it into a UI, and potentially you send that data into a storage, either long-term or cold storage, or short-term warm storage, depending on your needs. And so to recap, there are, from your device, you need to think about your hardware and your electronics. You need to think about the firmware that you might be writing and how you're interfacing with the enterprise cloud, either through HTTPS or MQTT. And on the cloud side, you have to think about how you're ingesting your data, what analyses are you running, and how you're storing your data. You want to think about the alerts that you might be triggering, any notifications that you want to make, or any other business logic that you want to put in place when that data comes in. And then finally, how do you visualize that data for the end user to make it the most impactful and the most valuable that it can be? So I know that was a lot to take in. Hopefully you found this to be an informative session. I guess now let me know if you have any questions. I'll pull up and I'll start monitoring the comments section, and I'll open this up.
Eric, okay. Eric, are you done?
Yep, all done here.
Okay, so Ricky, thanks so much for your presentation. I think it's very amazing, this combination of Power BI and all this architecture, mainly the part of Power BI. I remember we were in Microsoft Build and I was using Power BI to show the data. So thank you so much again for your awesome presentation. And yeah, and you can continue seeing us in the MSP Tech Days. You have much more presentations around the month of June and July too. And we have two closing events happening here in Brazil and in Peru, and many more countries too on the end of the year. And thanks so much, and thanks so much again for the presence of everyone. And see you.
Alrighty, thanks, Orlando.